G'day folks. Today I want to teach you the first mystery of quantum theory. Quantum theory has many mysteries, but this is the first one. It's the most special. I'm going to teach it to you using only basic mathematics, and I'm not just going to give you metaphors and analogies and stories. I want to teach you the actual quantum theoretic description. Now, we'll start off by talking about a very simple system which is going to be just a ball, and this ball can be either black or white. You might be thinking, hang on, quantum theory, isn't that about like atoms and photons and tiny things? And it's true, that's where we mainly use it. But if the laws of quantum theory are correct, in fact they apply at any scale. And so although the experiments I'm going to describe to you in practice we do slightly differently, in principle they can be performed exactly as I describe. So we have this ability to take this ball, and it can be either black or white. So this is going to be the white ball, and this is going to be the black ball. And we have many of these balls, but what we're going to do is we're going to drop them into a box. And this box kind of has a hole in the top and a hole in the bottom. And the label on this box is going to be not. Okay, strange label. But what we find is that when we drop a white ball into this box, it comes out black. Like this. So we drop the ball in here and it comes out here black. Conversely, if we drop in a black ball, then it comes out here white. So that's the origin of the name not for this box, is that the color that comes out is not the color that went in. It's a slightly funny name. So black goes to not black, i.e. white, and white goes to not black, i.e. black. Okay. So the not box just does a very simple thing. We don't actually ask the question what's going on inside this box. We just know that the effect on the color of the ball is to change the color. So here's the first question for you. What do you think happens if I take two of these not boxes and stack them one on top of the other? So I'm going to take not box number one. It's got a hole in the top and a hole in the bottom. And then not box number two, which also has a hole in the top and a hole in the bottom. And I'm going to drop, let's say, a white ball into the top of the first not box. What do you think is the color of the ball that we see? Well, it comes out white, because when it went through the first not box, it emerged black, and when it went a black ball going into the second not box, flipped it back to being white. So the combination of two not boxes, in fact, doesn't do anything to the color, because similarly, if we dropped a black ball in, then it would automatically emerge black. It would flip to white after the first one, and then from white would flip back to black. Okay, so the not box is not a particularly mysterious box. Okay, but there is a box that we can build which we do find really mysterious. It also has kind of a funny name, and the name is not particularly elucidating, so I'm just going to call that box after my friend Pete, who has built many of them. I'm going to call this the Pete box. And the Pete box also has one hole in the top and one hole in the bottom. And when you drop a white ball into the top of the Pete box, what you find is that some of the time it comes out white and some of the time it comes out black from the bottom. So maybe the first time you drop the white ball in, it comes out white, but maybe you drop a second white ball through and that one comes out black, and so on. So you can drop many white balls through the Pete box, And you just find some of the time they'll drop out white, some of the time they'll drop out black, and so you get it just a mixture. And we find there's no pattern to whether they fall out of the bottom black or white. It just seems to be exactly the same as if you flipped a coin. We look for patterns, we've never found any. Now similarly, if we drop a black ball into the top of the peat box, they also come out the bottom randomly black or white. Some of the time white, some of the time black, every single time just seems to be completely independent and just completely random. Now you could say, well, that's not a particularly strange thing. It just means that what we have going on inside the peat box is just something noisy, something strange, something kind of random, and you know, that just changes the color of the ball. And that could be the case, but we know in fact that it is not the case. And the way that we know is something rather magical. The way we know is that if we take a second peat box and we stack it below the first one, then what happens is, if you keep dropping black balls into the top, they all come out black from the bottom. And similarly, if you keep dropping white balls in the top, they all come out white. Now, can you see why this is strange? It's really critical that you do. You see, we think it's strange because if the black ball emerging from the first peat box is some of the time white or some of the time black, then it goes into the second peat box some of the time white, some of the time black. In which case, since both a black and a white ball going into the top of a peat box produce a random color at the bottom, we would expect there just to be still random black or white balls coming out the bottom. Okay. Let me say that again because it's really, really important. If the way a single peat box works is that a white ball comes out randomly black or white and a black ball comes out randomly black or white, then when I put two of them, one above the other, we expect that the ball coming out the first one is black or white, and so a black or white ball going into the second peat box, it doesn't matter whether it's black or white, it should still come out randomly black or white, but it doesn't. And that's actually a really mysterious thing. Okay. So what do you think we do as scientists when we see something like this? Well, our curiosity gets the better of us. We think, what color is the ball going into the second peat box? So what we do is we slightly pull the peat boxes apart and we just look. We shine a light in over here and we have a look to see what is the color of the ball partway, as it comes out of the first peat box and into the second. And now something that seems crazy when you first hear it happens. You see, if we see the color of the ball going into the second peat box, we see that it's sometimes white or black. And now we find that the balls that come out the bottom are also sometimes white and sometimes black. We go back to just having random colors at the bottom. Okay? So the very fact that we've observed what the color was between the two peat boxes has caused there to be some kind of change that makes the ball come out the bottom either black or white. Okay? i.e., our observations have changed something about the world. And we find, then we think, maybe we're just, while we're observing the ball, we're doing something which is just really messing around with it. So we try very non-invasive ways of looking at the color. We try gentler and gentler ways. And what we find is that if the method we use is so gentle that we cannot tell what the color is, then the peat boxes go back to behaving normally, i.e. black always comes out black and white always comes out white when we stack two of them. But as soon as the method we use is strong enough to tell us what the color was, then everything gets messed up and black comes out randomly black or white and white comes out randomly black or white. Okay, so how do we describe this situation? So actually in quantum theory what we do is we've built a formalism, some mathematics that describes for us how to talk about the ball when it's in between these two peat boxes. And this mathematics that we use, no one has ever found a different way of doing it. Sometimes we find things we think are different, but this is really the only way to do it, as far as we know. And in that mathematics, what we actually do is we invent a new word for what is going on with the ball between the two peat boxes. Because you see, if it was the case that the ball really was black or white, then it would emerge randomly black or white from the bottom here. So we know that somehow what is going on with the ball between the two peat boxes is that it no longer is black or white. So we can't use that word or. So what we do is we just create a new word and we say it's a superposition. And this is just physicists making up a word. Okay, we don't really know what is going on there, so we just say, well, we'll call it something different. We say the ball in between the two peat boxes is in a superposition, or it's a superposition of being black and being white. Okay, and the next thing we need to do is have a way to represent and to describe mathematically, because that's what physics does, what is going on with the balls as they go through the peat boxes. And the way we do that is as follows. We first kind of come up with a diagram that tells us how to describe after a white ball has been through the peat box. How to describe that ball as it comes out the bottom. Okay. But a white ball that comes out the bottom that we don't look at the color of it. And so we just have a diagram that does that. And I'm just going to draw it as a little cloud. And inside that cloud, I'm going to list both alternatives for the color of the ball. Because sometimes when we look at it, it's white and sometimes it's black. So our diagram has to capture that notion that the ball coming out of the peat boxes before we look at it is in some way white, it's in some way black. We say it's a superposition of white and black. And this little cloud, or mist as I'm going to call it, I'm going to call this the misty state of the ball because it's very mysterious. Okay? So this is the way we represent the ball that comes through one peat box. And the rule for what happens when a ball goes into a knot box or a subsequent peat box is then you just treat these configurations or colors of the ball, combinations of them, you treat them just as if they're kind of independent. Okay. Now, what happens if I put a black ball through a peat box? Well, something needs to be different because the initial color was different and somehow the second peat box knows that the ball initially was black. So we draw a cloud for this case as well, a mist. And now there's a distinction, and this distinction is really at the heart of the mystery of this mystery of quantum theory. The distinction is that we put a minus sign, a negative sign. Similar to when you have like a negative number, we now put a negative sign on the color of the ball. Okay, so this is just a strange thing. Maybe think of it as a negative label on the ball. I can't tell you why that arises, but nobody can. Okay, so this is really now the only distinction between the misty state of a white ball that comes out, an initially white ball after it comes out the peat box, and an initially black ball that comes out of the peat box. Now, why does this help us explain what happens when we do the two peat boxes experiment? It helps us because the rules of the mist are that if you look at a mist and there's different colors in there, then you just see one of the combinations of colors that are in the mist. And in this case, we would see with equal likelihood a white or a black ball. But the rules say if you don't look at the color, if you just send that misty state through a second peat box, then what you have to do is treat each of the colors in the mist, just treat them separately and independently. So send the white ball through and send the black ball through and just sort of treat them completely independently. So in this case you get a much bigger mist, okay, because this white ball splits into itself into a mist of two colors, of white and black. And this black ball also splits into two colors, white and negative black. Okay, so remember a black ball by this rule over here splits into white and negative black, and a white ball splits into white and black. So you see that going on here. Okay. So this is just a rule. Remember, this mist, you shouldn't think of it as necessarily, it's not that we see a cloud come out of the bottom of the boxes or something. It's a diagrammatic representation of the mathematics we use to describe this experiment. Now, you know from just arithmetic what happens when you kind of add a positive number and a negative number. And in particular, if you have a positive number like plus 42, and then you add to it a negative number like minus 42, then you get 0. They cancel each other out. And exactly the same thing happens in this diagrammatic language, because what happens with the mist is that the edges of this cloud kind of fade away. A mist within a mist is just a bigger mist. So here we go. And now we just have, you can think of it as one big mist. And inside this mist, there is a black ball that doesn't have a minus sign. You can think of it as like a positive black ball. And then here is a black ball that does have a minus sign. It's like a negative black ball. And they cancel each other out, just like when you do basic arithmetic. And that leaves us with a mist that only has a white ball in it. And so, after the second peat box, we only ever see a white ball. Okay. This is the way that quantum physics describes what happens in this experiment. It's just essentially cancellation, or we use the word interference, of these configurations of the colors of the black ball. Now, what about this case over here where I put a black ball into the mist? Well, in this case, let me erase this. In this case, if we put a second peat box, then we again get a bigger mist. And in this bigger mist, the white ball split into white and black. And the black ball, this negative black ball, splits into negative, a mist of white and negative black. Okay, now this is a little bit strange, but think about when you did mathematics. It's kind of like I've got this negative label, but then this ball here split into white and negative black. Now, do you know what's going to happen? Well, remember when you do mathematics like this, when you say negative of 2 plus negative 3 is equal to negative 2 plus negative negative 3. Well, a negative times a negative is a positive, so it just becomes a positive 3. Okay. Exactly the same thing is going to happen here. You can think of this mist as like the brackets that we're expanding there. And so when we remove this boundary of mist here, it behaves just like that mathematics over there. And we get a negative white ball, a bit like the negative 2, and a negative negative black ball. So let me erase that a bit better, which is just a black ball. Okay, so I get a negative white and a black. Here there is no negative sign to worry about. We just expand that out like this. And now you see that I have a white ball, a black ball, a negative white ball, and a positive black ball. So in this case, it's the two white balls that cancel each other out, that interfere with each other. And so we only get left with black balls. And this is the explanation of why it is that the black ball comes through the first peat box, comes through the second peat box, and emerges always black. Okay. Now, explanation. I gave you some rules and some mathematics, and for quantum theory that is actually about the best that we can all agree upon. We all agree that these are the correct rules. Nobody thinks that there's different rules. These ones work. These rules work for building your iPhone and the GPS system and everything that uses lasers. These rules really work. They work in practice. They're rules that work for engineers. But why the rules are like this, that is still a mystery. And in fact, things get worse once we start taking more than one ball. Okay, so here I've taken boxes where you just can drop through one ball at a time. But now we can build boxes where we drop through more balls, and we get even more mysterious things happening. But this, I've taught you, is the first mystery of quantum theory. If you want to understand some of the deeper mysteries of quantum theory, all explained with the same very simple basic mathematics, just the standard stuff that you learn when you study basic arithmetic. If you'd like to learn those, then get a hold of my book called Q is for Quantum. And I go through all of the remaining mysteries of quantum theory. And, well, if you read it, I hope you enjoy it.